While it's easy to overlook rivers, lakes, and reservoirs as we focus on the grander climate concerns of melting glaciers or rising sea levels, a quiet transformation has been happening beneath the surface of Earth's freshwater systems, one that may prove just as urgent. According to a new, wide-reaching study led by Utrecht University, the global freshwater oxygen cycle has shifted in a profound way, and for the first time, scientists are calling it what it is: a planetary emergency. Yet within this crisis, there is also clarity and opportunity, because what's human-caused can also be human-repaired, and this research might just be the lens we need to refocus on the value of freshwater as a living, dynamic, and recoverable part of Earth's system. The study offers a sobering finding: freshwater bodies are now consuming more oxygen than they produce. This imbalance, driven largely by agricultural runoff, excessive nutrient pollution, dam building, and warming temperatures, signals more than just environmental distress. It's an early warning system. Freshwater bodies, while occupying a relatively small percentage of the Earth's surface, play an outsized role in global cycles. They are intricately linked to oxygen exchange, nutrient transport, biodiversity, and even atmospheric chemistry. When these systems fall out of sync, the ripple effects are profound, touching everything from aquatic food webs to human health and water quality. Yet what makes this moment important is not only the revelation of the problem, but also the fact that scientists now have a full, global model of how the oxygen cycle in freshwater works. This is a scientific leap forward. Until now, our understanding of freshwater oxygenation was mostly fragmented, limited to isolated bodies of water or regional studies. What Utrecht's team has accomplished, by creating a detailed, predictive model of oxygen production and consumption on a global scale, allows policymakers and environmental managers to intervene early and effectively. It turns what was once a chaotic puzzle into something readable, measurable, and manageable. Even more strikingly, this study breaks down the myth that climate change alone is the main driver of oxygen loss. While warming does exacerbate the problem by reducing how much oxygen water can hold and accelerating oxygen-consuming processes, it's only responsible for about 10 to 20% of the issue. The bigger culprits are, in fact, things well within human control: nutrient pollution from fertilizers, poorly treated wastewater, and the engineering of water systems that slow natural flows and trap organic material in stagnant conditions. But here's where optimism fits into the picture. Because so much of the cause is directly tied to human behavior, the solutions can be, too. We already know how to reduce nutrient pollution, with better farming practices, stricter regulation of agricultural runoff, improved wastewater treatment, and restoration of wetlands that naturally filter out excess nutrients. Reducing the number of unnecessary or inefficient dams, or retrofitting them to better mimic natural flow, could also significantly ease the stress on aquatic ecosystems. These are not untested ideas. They've been implemented on smaller scales with success. The challenge is now scaling them up with urgency and coordination. There is also an opportunity to integrate freshwater oxygen monitoring into broader climate and sustainability agendas. For too long, lakes and rivers have been seen as local or secondary ecosystems, their management siloed off from bigger climate discussions. But this study makes it clear that these water bodies are global actors. They exchange gases with the atmosphere, support climate-regulating processes, and are sensitive barometers of planetary health. Including them in global climate models, conservation efforts, and carbon tracking is no longer optional. It's essential. Moreover, public awareness and local stewardship will play a powerful role. Communities around the world that depend on these waters for drinking, fishing, irrigation, and recreation have a stake in their protection. With better education, more transparent environmental reporting, and citizen science programs that allow people to monitor the health of their own rivers and lakes, we can harness grassroots energy to complement top-down policy change. What's happening is serious, no doubt. Oxygen loss in freshwater can lead to hypoxia, triggering fish die-offs, collapsing ecosystems, and degrading water quality, outcomes we're already seeing in many parts of the world. But there's something remarkably empowering about this moment. The threat is real, but so is the knowledge. We're no longer guessing, we're understanding. And understanding is the first step toward action. The freshwater oxygen emergency isn't just a crisis, It's a call to reconnect with the living water systems that sustain our planet. These rivers and lakes are more than scenery. They're breathing parts of the earth. And now that we know how they're struggling, we also know how to help them heal.